So if we ever need to find gravity on a value for g on the surface of a planet or an object, we can use the weight of that object. So this is the weight of the object, its weight force, and that will equal to the force acting on it as gravity. So we know we can use the weight force equation, but we can also use this other one for gravitational attraction. Well, that's the distance from between the two objects, d, mass of object 1 and object 2. So we're using object 1 here, and we get g, which is our value of 6.67 times 10 to the minus. Okay, make sure you're looking at the formula sheets to do these, and sometimes you'll see r squared instead of d squared, remember. If we divide both sides by m1, they cancel, and we're left with a value for g. It's the gravitational constant times the mass of the object of the planet, and this is the object of the planet here. So if it was Earth, that would be the mass of the Earth. Okay, so then we can use that formula and to find a value. So for say the moon, which has a mass of 7.36 times 10 to the 22 kilograms, we could put that in here, and we get times 7.36 times 10 to the 22 divided by, so it was at the surface of the Earth, so we need the moon, the radius of the moon. We'd put that in here in meters. I think we found out that's this, and square it, and we get a value of about 1.62 meters per second squared at the surface. Okay, so that's a way we can use this formula and this formula, combine them and solve for g here. It gives us a value. So the one you need to be able to get is this one. Thanks.